Hello, this is Gene Fay, CEO of ThreatX. Welcome to our educational series. Today, it's on a topic that we have a lot of passion about, which is the programming language Rust and why Rust rocks. With me is our co-founder and chief technology officer, Andrew Useckas, and Austin Jones, one of our senior software engineers. Welcome, guys. Thanks for taking the time to do this webinar. What I'd like to do is just give a quick overview of ThreatX. ThreatX is a web application and API protection platform, also called WAP, or sometimes called Next Generation WAF. And it's an exciting platform that's helping lots of major corporations solve application protection. And we do that by offering four key components: traditional WAF application protection, API protection, bot management, and DDoS layer 7. And these four capabilities on a single platform allow us to solve some pretty unique problems. I won't go any further than that because that's not the purpose of today. But if you want to learn more about ThreatX at any time, please visit our website and let us know, and we'd be more than glad to go into detail on that. So today we're going to, again, talk about the Rust language. Andrew, why don't you talk a little bit about what is Rust?
Yeah, so Rust is an S-generation language, I guess sometimes called fourth-generation language, that was developed by Mozilla in 2010. And they built the language basically because they needed something better for the browser. Most of the browser was mostly written in C before that, C, C++, I believe. And the issue with those languages, obviously, is buffer overflows, memory management problems, and things like that. So that's why they decided to come up with Rust. And Rust it's basically somewhere between the low-level C and higher abstract languages like Python. It allows you to do things as fast as Python, but at the same time, you can do a lot of system-level coding that you could do in C.
Great, awesome. And when you thought about designing our platform, why was Rust the language of choice? Maybe Andrew, you can lead off on that, and Austin, I'm sure you have some things you want to add to it as well.
Yeah, I'll lead off on that. So when we designed our product in the beginning, the language that we chose to code, at least our analytics platform in the beginning, was coded in Python. And we very quickly encountered that Python was just too slow for what we were doing. So obviously we are a WAF or WAP platform, so we make decisions in real time. And something like Python is just not good for something like that. I mean, if you need to make decisions at wire speed when, traffic is flowing through your sensors, Python is just not fast enough to do analytics on that kind of flow. So at the time, I started looking at the new generation languages, and basically the top languages at the time were Go, which is released by Google, and Rust, obviously, that's released by Mozilla. And I compared those languages. Both of those languages looked good to me. They were obviously faster than Python. They had interesting, syntax, and they lend themselves well to the use cases that we had. Why I chose Rust in the end was just a couple of points, and the first point was garbage collection. So Go still implements garbage collection, which basically means that you have an overhead in your executable. So when you're running real time, you still have to spend CPU cycles to go through the memory and collect all the objects and remove them. Rust does not have that issue. Rust is basically compile time memory management. If you can compile it, you can run it. You don't have to worry about any garbage collection. And in the end, I think I also liked the system level implementation and integrations that Rust provides. For example, you can easily hook Rust projects into current C libraries. That's very easy to do. You can even port C into Rust pretty easily. There are basically translation projects out there that allows you to do that. And Go was just not good for that stuff. So as far as our sensor was concerned, Go was just a no-starter. It was okay for an analytics engine, but not really a sensor.
Yeah, absolutely. And Austin, from your perspective as a new member of our team, any other things come to mind as to why ThreatX is best utilized on Rust?
Sure. So yeah, so at this point we use Rust for basically our entire backend infrastructure. So we use it for our sensor, we use it for the services that our sensors talk to, and for our REST APIs. And I think performance is one of the really critical ones. So in any language like Java or Python, the problem with garbage collection is that it adds tail latency. So at some point you have to release things, and often that's slow because as you've been servicing requests, you've been collecting a bunch of stuff, and all that needs to get cleared out. So what Rust really does great is it provides you that performance, but it provides you reliable, consistent, low resource usage in both memory and CPU. And that's really compelling for an environment like ours, where we have really performance critical request processing, and also fairly high volume streaming data processing. So I think it works quite well for those two use cases, and most of our platform really involves that kind of operation.
Yeah, makes sense. That's great. And I think we hit on a little bit of this, but when we talk about the why Rust piece of it, we definitely hit on the garbage collection. Are there other things, Austin, that you think about when it comes to why Rust?
Yeah, so Rust is great when you need performance, right? As we talked about. And one of the reasons why it's so great at that is that it makes it very easy to write low-level performance critical code that needs to deal with concurrency. So some of the safety that you get out of Rust doesn't only apply to single-threaded programs, it also applies to multi-threaded programs. So if you were going to try to write a concurrent streaming data engine in Java, for instance, you'd need to add a bunch of locking and sort of synchronization. And you basically need to whack-a-mole race conditions and concurrency problems. And Rust makes it much simpler to write programs that offer that safety from a logical perspective. And it also provides that safety from a security perspective. So compile time memory management makes the kind of security vulnerabilities in C, like user after free and buffer overflows that have plagued web browsers for the past decade. It just basically removes them. So you can write a WAF sensor that doesn't have those kinds of problems, and you can write you can write services that accept data that don't have that kind of high cost of stabilization and security maintenance. And the performance impact against high-level languages is really, really significant. So if you think about a 20x memory usage improvement, right? The same service doing the same REST API, 20x memory usage, you can deploy a lot more of those services for much cheaper, and they're faster as well. So there's a pretty compelling just cost reason to write a service in Rust. And when you really need that performance, it becomes even more compelling. So Rust allows us to write fast and go fast.
Makes sense. Great. And what are some of the challenges, Andrew, as the CTO? What are some of the major challenges that we faced when we chose Rust?
Yeah, the biggest challenge from the beginning was always finding the resources, finding coders that can code Rust. And the market is better now, but in the beginning, basically nobody knew what Rust was or how to code in it. So we had to basically find C coders that could also do Python or Java, basically people that can code in multiple languages and also were familiar with system level code. And then basically teach them Rust. But these days it's getting much better. I mean, Rust is, the ecosphere of Rust is expanding. The libraries are, as they called, crates in Rust. I mean, there are more and more of them every day. And people that try to code in Rust really like it and stay with Rust, or try to stay with Rust as much as possible. It's one of those languages that I think there was some kind of poll done basically as to, do you like the language that you write in? And Rust came out with like screaming colors. People love the syntax, people love what they're doing in it. That being said, it is not an easy language to learn. It it is quite a steep learning curve, even if you come from the background of C, C++, and Python and Java and all of these, and even Haskell and Erlang and all of these languages combined together, there's still pretty steep learning curve. But once you figure out the memory management, once you figure out the lifetimes, it becomes pretty easy and pretty intuitive and easy to code in.
Great. And what are the major advantages that we've enjoyed? Austin, why don't you take us through some of these things that have really been the ultimate benefits for us?
Sure. So I think we've covered the performance and ROI on developing stable software. But Rust was initially designed for the low-level things, right? But as it's grown, it's gotten a very great ecosystem of high-level APIs and interfaces. So when you think about, I want to write a REST API, right? The things you're going to need for that are, serialization and databases, database libraries, and high-level functional programming. So stuff like map, filter, and fold are things that you wouldn't find in C, right? But Rust really provides those high-level interfaces when you need them and gives you the tools to dive down into low-level, really performance-critical code when you really have to. And there's a really vibrant open source community. There is, there are async runtimes like Tokyo. There's REST platforms and web services like Actix Web and Rocket and Warp. And so more and more, it's becoming easy to do high-level things and solve high-level problems while still sort of enjoying this foundation of performance and safe concurrency. So ThreatX engineers ourselves have contributed libraries with over 50K total downloads on the Crate registry.
Wow!
So we've been giving back.
That's impressive. So Andrew, how would you basically summarize this for the people that are trying to evaluate maybe some two guys and a gal in the garage starting to think about some sort of high performance environment, maybe a cybersecurity solution? Why does Rust rock?
Yeah, I think, when it comes to high performance, if you need high performance, Rust is a no-brainer. Yes, you have a choice between Go and Rust. But, garbage collection is one of those things you either can live with it or not. And it's up to you in the end to decide if you want to deal with the learning curve of Rust. But in my opinion, it's well worth it in the end. And definitely, it paid dividends in our case. I mean, when we ported our Python project, our analytics engine, into Rust, the increases in speed were monumental. I mean, we're talking 50 to 100 times. And if you're comparing C versus Rust, it's also a no-brainer, because who wants to deal with, spending days and days in Valgrind trying to, troubleshoot all the memory issues. In Rust, it's not an issue. So yeah, I mean, for me, it's a no-brainer. I will stick with Rust until something better comes around, if something better comes around.
Well, I'll just, kind of second what you said, having joined the company 10 months ago and coming from places based on C++ and other, where we're continuously hearing about the team trying to figure out memory leaks and things like that. It's simply not an issue we hear about. And performance for our largest customers on global deployments, I'm so glad that you and the team picked Rust because we're able to deliver for a relatively small organization on some massive deployments, and that has everything to do with starting with the right language. So thank you for doing that, and Austin, just great job continuing to expand on what we built in terms of capabilities. So with that, we'll wrap up the ThreatX educational webinar. We thank you very much for being a participant. And if you have any questions about Rust, I'm sure you can find us on the internet. And Austin and Andrew will be more than glad to answer any of your questions about Rust. And maybe you have some specific use cases you want to bounce off us. Please reach out. We're more than glad to help any way we can. Thanks a lot and have a great day.
Thank you.
Thank you.